lesson, we will be applying our knowledge of like terms and adding and subtracting to add and subtract polynomials. The two things to remember when you're adding and subtracting polynomials are to identify and rearrange your like terms and to combine your like terms. This first example is a three-term polynomial. We're going to first identify any like terms. Remember, a like term is the same variable raised to the same power. In this example, we have two like terms, 12p cubed and 8p cubed. To add these like terms, you simply add the coefficients. So our answer becomes 12 plus 8, or 20p cubed, plus the remaining term, which is 11p squared. The same can be done when there are subtraction examples. For example, 5x squared minus 6 minus 3x plus 8. If you'd like to physically rearrange them using commutative property, that's fine. If you want to just identify them, perhaps by drawing a single line underneath each different like term, you may do so. In this example, we have the term 5x squared. It is the only term that is to the second power, so we will not be adding or subtracting that to anything, and that will be our leading term. Whoops, 5x squared is our leading term. The second term that we have is a negative 6. We have a negative 6 and a plus 8. These are like terms because neither one has a variable, they are constants. We know that negative 6 plus 8 equals 2, so we will write 5x squared plus 2. This leaves our remaining term, which is negative 3x. It has nothing to add or subtract to. There are no other like terms, so we'll write minus 3x. Now remember, we can write this in standard form by writing the degrees in order from greatest to least. So 5x squared, which has a degree 2, minus 3x, which has degree 1, plus 2. Remember, constants have degree 0. One more example of this type, t squared plus 2s squared minus 4t squared minus s squared. Remember, if we do not see a coefficient, it is a 1. Now let's identify the like terms. My first term is t squared. I have one other term in this polynomial that is also t squared. But remember, when you're subtracting, you have to keep the negative sign by the coefficient of 4. So I'm going to think of this as 1t squared minus 4t squared. 1 minus 4 is negative 3. So my leading coefficient becomes negative 3. And my leading term is negative 3t squared. The second term is 2s squared. My variable is s raised to the second power. This is a like term. Negative 1s squared is a like term because, again, we have s raised to the second power. 2s squared minus 1s squared is 1s squared. So my final answer is negative 3t squared plus 1s squared, which I can simplify. Negative 3t squared plus s squared. In our next set of examples, we'll be looking at polynomials that are a binomial plus a binomial, or a binomial plus a trinomial. Now you can continue looking for and identifying like terms. A second way to think about this, however, is to add them vertically instead of horizontally. To add two polynomials vertically, you simply line up terms that are like terms. So right underneath the 4m squared, I'm going to put m squared. I'm going to rewrite this for you. 4m squared plus. Now I don't have anything to the m power, but I'm going to put 0m plus 5 so that I have a placeholder. Now I'm going to add m squared minus m, go right below the 0m, and I can put a 1 there, plus 6. have another coefficient that I don't see, so I will put a 1 there. 4m squared plus 1m squared is 5m squared. 0 minus 1m would be minus m, and 5 plus 6 is 11. So my final answer is 5m squared minus m plus 11. And I've added that horizontally. The second example, 6x squared minus 4y plus 3x squared plus 3y minus 8x squared minus 2y. Before I begin adding the first polynomial to the second one, I noticed that my second polynomial has like terms within it. So I'm going to clean that up first. I have 3x squared minus 8x squared, which becomes 3 minus 8, or negative 5x squared. I have a positive 3y minus 2y. 3y minus 2y is just plus y. Now I have simplified my second polynomial, and I will add the first polynomial to that. Each of them are binomials. They each have 2 terms. So I'll simply look for my like terms. I have a 6x squared minus a 5x squared. 6 minus 5 is 1, so that answer is 1x squared, or just x squared. And I have negative 4y plus 1y. Negative 4 plus 1 is negative 3. So my final answer is x squared minus 3y. Sometimes you'll have to add polynomials that contain fractions. We use the same method. This is still my second level of examples. We have 1/2 a squared plus b plus 2. And I'm going to add 3/2 a squared minus 4b plus 5. I think I'll add these vertically. So I'm going to take the second polynomial and write it underneath the first polynomial, lining up my like terms. So I have 3/2 a squared minus 4b plus 5. If you want to know about fractions, 1/2 plus 3/2 is 4/2, but 4/2 equals 2. So 1/2 a squared plus 3/2 a squared equals 2a squared. I have a 1b minus a 4b. 1 minus 4 is negative 3. So I have negative 3b, and 2 plus 5 is 7. So my final answer is 2a squared minus 3b plus 7. I have one more level of examples to show you, and that is using subtraction. The thing to remember when you're subtracting is that when you subtract, you're adding the opposite. So in this third level of examples, we're going to rewrite our second polynomial as addition. X cubed plus 4y minus 2x cubed. We're going to rewrite as x cubed plus 4y plus a negative 2x cubed. Now I simply need to add 1x cubed minus 2x cubed is equal to negative x cubed. And I'm going to add 4y. It has no like terms to be added or subtracted. So my final answer is negative x cubed plus 4y. Looking at a longer example, 7m to the 4th minus 2m squared minus 5m to the 4th minus 5m squared plus 8. I'm going to rewrite as addition, leaving the first polynomial alone. I'm going to add the opposite of each term in this second polynomial. The opposite of 5m to the 4th is negative 5m to the 4th. The opposite of minus 5m squared is plus 5m squared. The opposite of 8 is negative 8. Now, looking for my like terms, I see 7m to the 4th minus 5m to the 4th, which is 2m to the 4th. I have a negative 2m squared plus 5m squared. Negative 2 plus 5 is a positive 3. That gives me 3m squared. And I have a constant in the second polynomial. So that's negative 8. My final answer is 2m to the 4th plus 3m squared minus 8. Two more examples. Using the same level, we have negative 10x squared minus 3x plus 7 minus x squared minus 9, which becomes negative 10x squared minus 3x plus 7. This first trinomial that has three terms plus the opposite of x squared, which is negative x squared, the opposite of negative 9, which is positive 9. Negative 10x squared minus 1x squared is negative 11x squared. I have no x term in the second polynomial, so I'm going to write minus 3x, bringing it down. And then I have my constants. I have a 7 and a 9. 7 plus 9 is 16. And my final answer is negative 11x squared minus 3x plus 16. One more example. 9q squared minus 3q minus q squared minus 5. Again, write the first polynomial down as written. I'm going to add the opposites, which becomes plus negative q squared, which is the opposite of q squared, plus 5, which is the opposite of minus 5. 9q squared minus q squared is 8q squared. I have a negative 3q that I'll just bring down, and a positive 5, which I'll just bring down. My final answer is 8q squared minus 3q plus 5. Remember, this is a trinomial because it has three terms, and it's also quadratic because it's raised to the second power. So putting together more and more of what we've learned, you should now be able to add and subtract polynomials. Thank you.